This lesson is on position, velocity, and acceleration word problems. Our learning goals for today are we're learning to solve problems that involve position, velocity, and acceleration. And the second one, we're learning that velocity is the rate of change of position with time, and that acceleration is the rate of change of velocity with time. In this course, we will consider an object to be moving along a straight line only. So the questions will be pretty straightforward. It can speed up or slow down, it could stop, it could change direction, but it's all taking place up and down a straight line. And I usually think about that straight line being a horizontal straight line. So we can go forwards, backwards, forwards further, okay, but it's always along a straight line. The position function of the object will be given as a function of time, and you'll see it being called s at t for position instead of p at t, but that's what it's normally called, s at t. And I think we've used that before to represent position. The velocity of the object then can, since the rate of change of position with time would be s prime at t, okay, or just the first derivative of s at t. But we can say then that v at t is s prime at t, okay? And that's velocity at time t would be the first derivative of position. So, and I've got that right here, i.e. v at t is s prime at t. The acceleration of an object can be found by taking the second derivative. Okay, so a at t is s double prime at t, or because v at t was s prime at t, a at t is v prime at t. Okay, so easy to think of. Here's our first question. We'll go through it and see if the stuff's going to make sense. So the position of a particle moving along a straight line is given by that function. S at t is a sixth t cubed minus a half t squared minus t, where s is measured in meters and t is measured in seconds. And t belongs to the interval 0 to 4, okay, including 0 and 4. So only valid between 0 seconds and 4 seconds. So it wants us to find the velocity and acceleration as functions of time. First, okay, so that's just using what we have newly found out here, and that is that v at t is s prime at t, which, if this is s at t up here, would be 3/6 or 1/2 t squared minus 2 times a half, which is 1t minus 1. So that's v at t, okay? So find the velocity as a function of time. We just did that. So, oh, that's not B, it's a continuation of A. So now we want to find acceleration as a function of time. And that's v prime at t, the derivative of velocity with respect to time. And we just found out v at t, so we're using this v at t we just found. When we decide to differentiate it, we get a at t is equal to, so 2 times a half is 1, t minus 1. So there we've got our formulas. V at t is a half t squared minus t minus 1, and a at t is t minus 1. So now we're moving on to B. Find the velocity and acceleration at time is 2 seconds. So we just need to, for velocity at 2 seconds, we just need to substitute 2 into the formula that we made. So that's 4 times a half is 2 minus 2 minus 1, which gives us -1 meters per second. So that's going to mean at 2 seconds we're moving back towards the origin. If we're moving along a straight line, we're moving away for a certain amount of time. And remember, this only works between 0 and 4. And then, but at 2 seconds we're moving in the negative direction, so we're moving back towards the start if this is the start. Okay, that's what a negative would mean. And we also want a at 2, so our acceleration at 2 seconds is 2 minus 1, which is 1. And the units of acceleration are units of measurement, so in meters in our case, per time squared, and we're measuring time in seconds. Okay, so if you're not a physics person, the units of acceleration are meter per time squared, whatever time is measured in and whatever distance is measured in. And C, in which direction is the object moving at t equals 1 second and t equals 3 seconds? So let's find the direction an object is moving. So it's either our directions are going to be towards the start or away from the start. So v at 1 is a half times 1 squared minus 1 minus 1. So that's a half minus 2, which is negative 3 over 2 meters per second. So that means we're moving towards the start, we think, but what if at 1 second we were already on this side moving in this direction? We're moving backwards. We'd be moving away from the start, but in a negative direction. Okay, so in order to know that, we want to compare s at 0, which if we sub 0 in up here, we would get 0 meters, and s at 1, which is a sixth, minus a half, minus 1, which is a sixth, minus 3/6 minus 6/6, which is negative 7/6 meters. Okay, so that means if we started here at 0 meters, 1 second later, we're at negative 7/6 of a meter, so we're over here. And at this time, so this is at 0 seconds, this is at 1 second. And we're still moving in this direction at a speed of negative 3/2 meters per second. So that means we're moving away from the start, not towards the start. Okay, so let me move this up. So at 1 second, the object is moving away from the start position. So let's find v at 2. So that's a half times 2 squared minus 2 minus 1. We'd already figured that out here. That was negative 1 meters per second. But let's also find s at 2. So we know where we are here. So that's going to be a sixth times 2 cubed minus a half times 2 squared minus 2, which is 8 over 6 minus 2 minus 2. So that's going to be, if we do it all in sixth, sorry, that's 12/6. So that's going to be negative 4 and negative 16/6 meters. So we're even further beyond here, and we're still moving in the negative direction. So at 2 seconds, we are moving away from the start position. And we're moving backwards. We realize that in both cases. We're at here at negative 16/6, which is a lot bigger than negative 7/6, so over here somewhere. And then we're moving at a different speed, negative 1 meter per second, but we're still moving in that direction relative to positive being right, if we have that as our scheme. All right, so if we move on to our second question. So we've got the position function of a cheetah moving across level ground in a straight line chasing after its prey is given by the function s at t is t cubed minus 15t squared plus 63t, where t is measured in seconds and s is measured in meters. So A says, what is the cheetah's velocity at 1 second, 4 seconds, and 8 seconds? So first I would find v at t, which is s prime at t, so 3t squared minus 30t plus 63. And I want v at 1, which turns out to be 36 meters per second. We want v at 4, which turns out to be -9 meters per second, and v at 8 which turns out to be -15 meters per second. So we found our, just fill in these therefore statements. And therefore v at 4, and therefore v at 8. B, when is the cheetah stopped? So when is the cheetah stopped? You have to realize that something stops when its velocity, v at t, is equal to 0. So we've got velocity here. We already found it. And we want the time when its velocity is 0. So I think I'm going to factor the 3 out here. See if it's easier to solve. And often you'll find that this trinomial in here, or it might be a difference of squares. Anyways, it will be factorable. And in this case, t minus 7, t minus 3 factors. And then if we solve, we get t equals 7 seconds and t equals 3 seconds. So therefore, the cheetah is stopped at t equals 7 seconds and t equals 3 seconds. So, but it stops first at 3 seconds and then again at 7 seconds. And we're considering, remember, the cheetah's running in a straight line. It can stop, then it can turn around, it can go back and forth, but just in a straight line. Very, very simplified examples. So C, how far from the cheetah's starting position is it when it is stopped? How far from the cheetah's starting position is it when it is stopped? So C, first we would want to know what S at 0 was so we can compare. And that turns out to be 0 meters, so that's easy. So we know it's stopped at 3 seconds, so we want to find S at 3. Which is going to give us -81 meters. And then we also want S at 7. Oops, I've made a mistake here. Just made it again. No, I'm not. I'm doing it fine. Sorry. I was looking at B for a second, but we want to know. We want to use this one. So I'm doing it right. Plus 63 times 7. So 7 to the power of 3 minus 15 times 49 plus 63 times 7. 49 meters. Okay, so how far from the cheetah starting position is it when it is stopped? At 3 seconds, it is 81 meters from the start. And at 7 seconds, it is 49 meters from the start. So you can see that the cheetah has changed directions at 3 seconds. It's gone 81 meters away, but at 7 seconds, it's only 49 meters from the start, so it has to have gone back along that straight line. D, when is the cheetah moving away from its starting position? So we can use that information that we just got here. So we know that S at 0 is 0 meters. And even though this is a straight line, I'm gonna like curve it around just so that you can see what I'm doing here. So we're gonna keep moving in this positive direction. We know V at 1, we're moving in a positive direction until usually we only change direction at stops. That's a good rule of thumb. So the first time we change direction and start going back this way, even though it's really on a straight line, but it's hard to draw over top of another line. So we're going to say this happens at t equals 3 seconds, and that this position is S at 3 is 81 meters. And then now we're moving back this way until 7 seconds. So, and then we're going to move back this way again. So at t equals 7 seconds, we are 49 meters away from the start, rather than 81 meters away from the start. So if you look at this picture, we're going in a positive direction away from the start. Then at 3 seconds, we're stopped for an instant, and then we start going back towards the starting place. And then at 7 seconds, we stop again for an instant, and then we change direction again, and then we don't change. We never change. Since they didn't give us a restriction up here for how long the cheetah is actually running. So our answer is going to be a bit nonsensical in a way, but from what we've got here, our analysis, we can say that the cheetah is moving away from the start over the interval. So t belongs from 0 to 3 seconds, okay, and it stopped at 3 seconds, so we're going to use an open interval. And v at 0, it is moving, but we'll use an open interval. So from 0 to 3 seconds, the cheetah is moving away from the start, and the other interval is from 7 to infinity, 7 seconds to infinity. Okay, so those are the two time intervals over which the cheetah is moving away from the start. It's moving towards the start from 3 to 7. E, find the position of the cheetah at time t equals 10 seconds. So that's just S at 10, which is going to be 10 cubed minus 15 times 10 squared plus 63 times 10, which we can calculate. Which gives us 130 meters. So find the position of the cheetah. Therefore, position of cheetah is 130 meters from start. And F, find the total distance the cheetah has run during the first 10 seconds. So to find the total distance, we have to find from here to here. Okay, and the way we do that is we're going to say it's the absolute value of S at 3 minus S at 0. Plus, then we've got to find the distance from here to here, which is the absolute value of S at 7 seconds minus S at 3 seconds. And we're using absolute values because we're going to keep adding these distances. We always want them to be positive. Plus the absolute value of S at 10 minus S at 7. And then we have numbers we can fill in here. So S at 3 we found out earlier. Uh-oh. I got you down to C, I think. So you couldn't see what I was doing for D. So I'll go back over D again. So D was, when is the cheetah moving away from its starting position? So I figured out S at 0 by substituting into the original S at t formula and got 0. At 3 seconds, we figured out that S at 3 was 81 meters. So I'm stopped here at 3 seconds, and this is where I said you can't drop back over top of. It's hard to drop back over top of where you were drawing. And then we figured out that at 7 seconds, again when we're stopped, we're only 49 meters away from the start. So we've gone back in this way. And then every time you stop, you change direction. So we've curled around and gone back this way. Okay, this is really all happening on a straight line back and forth, but I'm trying to exaggerate it to show you. So then we figured out the cheetah is moving away from this starting position over the interval 0, t belongs to 0 to 3 seconds, and then from 7 on, so and 7 to infinity. And then E was just to find S at 10, which we did, okay, just by substituting into the formula. So we got the position of the cheetah is 130 meters from the start at 10 seconds. So F, this is where we're finding the total distance the cheetah has run during the first 10 seconds, and we use absolute value notation so that we never end up with a negative distance that we're adding in. That's making the total distance traveled actually smaller. Okay, so first we're going to do this stretch here from 0 to 3, so S at 3 minus S at 0. And then we're going to do this stretch here, so S at 7 minus S at 3 we're adding in. And then because we're going up to a total of 10 seconds, position at 10 seconds minus position at 7 seconds. So S at 3, if we just look at our calculation, was 81 meters minus 0 meters, plus the absolute value of 49 meters minus 81 meters, plus the absolute value of 130 meters minus 49 meters. That's at 7. So that's going to be the absolute value of 81 meters plus the absolute value of negative 32 meters plus the absolute value of 81 meters again, which would be, so this is distance, the absolute value of 81 is just 81 plus 32, absolute value of negative 32 is positive 32, plus 81 again, giving you a total distance of 194 meters. So find the total distance. So therefore cheetah ran 194 meters in first 10 seconds. Okay, sorry about that. I'll try to keep in mind where the camera fits for the last question. All right, so here we go. The position of a particle moves along a straight line and is given by the equation S at t equals 2t cubed minus 21t squared plus 60t, where t is greater than or equal to 0. T is measured in seconds and S in meters. What is the velocity of the particle after 3 seconds and after 6 seconds? So again, this one should be pretty straightforward. We're first going to find v at t, which is S prime at t. So that's going to be 6t squared minus 42t plus 60. And then we want 3 seconds and 6 seconds. So v at 3 is 6 times 3 squared minus 42 times 3 plus 60. Which gives you negative 12 meters per second. And then we also want v at 6, which is 6 times 6 squared minus 42 times 6 plus 60. Which gives us 24 meters per second. B, when is the particle at rest? So again, we know that's when v at t equals 0. So 0 is 6t squared minus 42t plus 60. Again, I'm going to try factoring out. And again, this trinomial factors t minus 5 and t minus 2, giving us t is 5 seconds and t is 2 seconds. So therefore, particle at rest at t equals 2 seconds and t equals 5 seconds. C, when is the particle moving towards its starting position? So again, we'd first find out where is its starting position. So S at 0 is 0 meters. And then we care about when it stops the first time. So S at 2, 2 times 2 cubed minus 21 times 2 squared plus 60 times 2. Which gives us 52 meters. And also S at 5. So that's going to be 125 times 2 minus so that ends up giving us 25 meters. Okay. So starting out at 0 meters, if we start our diagram here, S at 0 is 0 meters, and we also know V at 0 is, we sub 0 into V at t, we get 60, so we're moving in the positive direction until we stop the first time. So the first time we stop is at t equals 2 seconds, and we are at a position of 52 meters away from the start. And then we're going to change directions until 5 seconds when we're only 25 meters away from the start. So this is t is 5 seconds and S at 5 is 25 meters, and then we continue to move away from the start forevermore because they don't give us an ending time. So the question was, when is the particle moving towards its starting position? So towards is just from 2 seconds to 5 seconds. So we could do a therefore particle is moving towards the start from t belongs to 2 to 5 seconds. D. Find the total distance traveled in the first 6 seconds. So we need to find S at 6 first, but that's not the answer. That just gives us the position at 6 seconds. So S at 6 is 2 times 6 cubed minus 21 times 6 squared plus 60 times 6, which gives us 36 meters. So again, this total distance, we're going to do the first chunk here from 0 to 2. So S at 2 minus S at 0 plus this next chunk in here is going to be the absolute value of S at 5 minus S at 2 plus this last chunk we get cut off at 6. So S at 6 minus S at 5, which is the absolute value of 52 meters minus 0 meters plus 25 meters minus 52 meters absolute value plus the absolute value of 36 meters minus 25 meters. So it's the absolute value of 52 meters plus the absolute value of negative 27 meters plus the absolute value of 11 meters, which is 52 meters plus 27 meters plus 11 meters, which is 90 meters. So therefore the total distance traveled in the first 6 seconds is 90 meters. And that is the end of the lesson. Our success criteria for today are that given the position function, S at t, you can find the velocity and the acceleration, V at t and A at t. You can determine when an object is at rest. You can determine when an object is moving in a positive and negative direction. Know an object only changes direction when it momentarily stops. You can determine whether an object is moving towards or away from its starting point, and you can determine the total distance an object has traveled over a given period of time. And then the practice is on the sheet.
Thank you.